meeting at a time.
Nope, I'm coming here.
Am I coming through loudly enough?
You are. You sound great.
Okay, good.
That's picking up some of the participants.
Uh-huh.
But that's getting more than it's like that other shot.
Yeah, that's
was,
better.
so.
Okay, we're just running a couple minutes behind, I think.
We'll have to
So
look at
give
it.
us about 5 minutes.
No problem.
Find funding for what it can.
Is that this side or is that that side? So we'll get everybody's little bit. Let's see here.
Closer to the week.
Should we send a reminder this morning so the people that yeah, anywhere over here, this would be great, because then,
Okay. Sure.
because the cameras have a
Yes.
odd angle.
I see.
Alright, well, I don't know what he's at, but we got lots of food and help yourself.
Yes.
Yeah.
Okay.
So I'm gonna move myself over here, just in case. This. How are you? Just got an email. Have a seat. We have 40 people signed up, but I don't know where they are, so we're gonna start regardless. In just a minute. There's my we're sitting over here on this side because that's where the camera sits.
Okay,
If you don't mind.
No. I might have to leave a little early. Okay. Good morning. I'm so excited about this.
We have 40 people signed up,
Oh, excellent.
but they're not here, so I'm not sure.
Yeah, I'm having deja vu to many of the library classes that I teach.
Do they think it's an FSC
I don't know.
2009?
Teresa Kennedy just emailed me and said,
Oh,
can you send me the link? I can't get in.
oh, do they think it's for the Zoom webinar? Are they attending the Zoom?
They can.
Oh, maybe that's.
Let's see. But we have people in Zoom. Something's wrong because like Teresa Kennedy says she can't get in to Zoom.
Maybe that person.
And so I don't know.
You started the meeting?
Yeah. I mean, we
So
have,
it must be
we have
her.
some people there, but we don't have all the people that signed up. I'm kind of worried that. Let's see.
I mean, if other people were able to get on, it's not the Zoom.
We have one.
Okay, then it's not the link.
Okay, I don't know what's.
I was able to join,
Viewer.
she just chatted.
Okay.
Maybe if you just send her the number,
Yeah,
meeting number, sometimes they get
do it on my phone. She says, I was able to join via the link. Okay. So. Thank you, Christy. Yeah, we'll get started in just a second. Let me send this link. Just go with my part to leave. I'm going to forward this to, and then we're going to get started. We'll just go with what it is. Okay. See, I'm going to make it look kind of confusing. All right, anybody else want something before we get started? We're going to get started. Just spare our time.
Yeah, no, it's fine.
Okay.
I'm very excited. Where's the camera? I don't even see it.
I know, it's because the president, I think it's there.
Oh, I see it. I see it. Yes, it is.
Right. Mariel, can you hear me?
Are we ready?
We are. We're going to go ahead and get started because we're missing a few people and it's Monday. So, there may be some people that come in a few minutes late. The parking is kind of hard on campus this morning. I don't know why, but there were no parking spots. Mariel Hardman, Dr. Mariel Hardman is the Vice Dean of Academic Affairs and Professor of Clinical Education and co-founder and director of the School of Education's Neuroeducation Initiative. And we are super excited to have her. She was sought after because we had faculty who actually asked for brain-based strategies for the classroom. And so we looked for, who is the guru in that area? Who does, neuro work with students to, increase teaching and learning capacity. And so Mariel was so willing to come in and talk to us, and we rescheduled, and she came back and, still came back and talked to UT Tyler. So we're very excited to have her today. And I'm going to kind of turn her work over and let her talk about what she does with you. You ready?
I am. Let's move it on. Good morning, everyone. And thank you, Julie, for inviting me. So I want to move right into what we do here at Hopkins and an initiative that we call the Neuroeducation Initiative. When I first came to Hopkins around 11 years ago, I had already created the brain-targeted teaching model for K-12 educators. But what I found was that there were 540 researchers across all of the different units dealing at Johns Hopkins with some area of neuroscience or cognitive science or experimental psychology. And none of them were researching with the idea that educators, whether they are in preschool classrooms or higher education classrooms, that educators would be recipients of this work. So I created the Mind, Brain, and Teaching Graduate Certificate, which also now is in our doctoral program at Johns Hopkins. So I'm proud to say that the work that we do with the brain-targeted teaching model is something that pulls together what we've learned, and there's more and more research every day coming from what we're say broadly is the learning sciences, and then putting it within a framework called the brain-targeted teaching model, which, as I said, I originally focused on K-12 educators as those that the model will be able to use, teachers at the model, and then found that once the model got out there, that we have a group of preschools in India, for example, that started their whole preschool franchise based on brain-targeted teaching. And then I found many higher educators who found the model and have adopted some or all of its components into their own teaching. In fact, Hopkins has a teaching and learning institute here that is geared toward helping either early career faculty or even seasoned faculty learn more about how to reach their students. So we use it here at Hopkins with our own faculty. And so we look to see how this then informs both formal and informal learning. So as I said, the brain-targeted teaching model was built on the learning sciences, cognitive psychology, experimental psych, and then teaching skills frameworks that we've been using for a long time, like dimensions of learning or Bloom's taxonomy, multiple intelligences. So there are 6 components of the model, as you can see in this illustration. So I want to go through each of the 6, and we'll look at some of the research that supports the various components, the emotional climate, the physical environment, using big picture concepts to design what you're doing, what you're teaching, looking for how your students master what you're teaching them, how they apply it, and then evaluating learning. So in this hour, we'll go through a lot of this quickly. Typically, the brain-targeted teaching model is about 30 hours of instruction. And so we've done this. Again, our courses are actually 30, 45 hours of instruction. And we've done professional development that have been about the same length of time. But I also like to give groups a little taste of it in, a 1-hour time frame, which I'm doing today, and encourage you to, if you're interested, to delve deeper on your own, or maybe come to one of my sessions. I regularly speak at the Learning in the Brain conferences. So let's start with what should instructors know from the brain sciences. So there are some broad general findings that I think more and more people are getting to know because it's in popular media now. But the idea of plasticity, that the brain changes with experience and it changes in structure and chemistry. The idea that the brain continues to grow new cells at any age, and that's a much more recent finding. 20 years ago, neuroscientists would say, well, we know that the brain continues to grow in terms of connections, which is what plasticity is called, connections among brain cells, but that the brain doesn't actually grow new cells. And now we know that's not true, that the brain grows cells even up until in your 90s. We're learning a lot more about emotions and learning, and we'll be spending some time on that today. We also know that there are certain windows of opportunity that exist for critical brain changes, and we'll talk about that time of adolescence. And those of you who teach undergraduate students will know that they probably fit into some of that, that span. Learning and memory, we know that memory can be strengthened, and we'll talk about ways that we do that. We'll talk about ways that physical health, exercise, hydration, sleep have influence on it. The research that my team has been doing here is looking at the effects of arts on learning, and actually how the visual and performing arts can enhance attention and memory. And then finally, we know that attention can be enhanced through various things, and we'll be looking at the physical environment and then specific training. So I'd like to start out with what is not true about learning in the brain, and it's something that we call neuromyths. So myths and neuromyths, so what are they? So I start out with this picture. This is actually a real advertisement. More doctors smoke Camels than any other cigarette. So we laugh at that now. I mean, obviously that's probably not true. And, a good way of advertising, right? Camels must be good for you if doctors smoke them. But that's a myth that we just accepted as reality. Or how about this one? For a better start in life, start Coca-Cola earlier. So through through our history, there are certain things we have accepted as true. When we find out later and laugh back at them now and say that's not true at all. Well, here are some myths in education that I would say are parallel. First of all, that there are critical periods when certain things must be taught. You can't teach an old dog new tricks. And what we know now is that's really not true. I talked about sensitive periods earlier and the fact that there are certain times when the brain is working really hard. And we'll talk about that with language, for example, language development. But we can learn anything at any age. And so those of you who are teaching young adults, you may hear them say things like, you know, I'm just not good at math. I don't get it. Or, you know, stats never made sense to me. So I'm probably not wired to do that. Or even a foreign language, you know, it's too late for me to learn a foreign language. So actually, it's not too late to learn anything. What I typically say is that you can learn to play the tuba as an adult, but just don't book Carnegie Hall. You only use 10% of our brain. That is a myth that I still hear out there. There was a movie called Lucy not long ago that was built on this false premise. No, we use all of our brain. That came from a little bit of research a long time ago on rats when they were removing different sections of the rats to see how it affect performance, and they weren't seeing a difference in performance. And it was really only because other areas of the brain were sort of taking over for that function. So what the researchers then assumed was that a lot of the brain was useless. And so again, that's a complete myth. When I talk to teachers, especially those who teach adolescent boys, and I say, you know, I wonder what people think the other 90% of the brain is busy doing. Teachers of middle school boys usually tell me what they think they're doing. I'm left-brained, you're right-brained. We know that the left and right side of the brain is very localized. Left brain is very heavily wired for receptive and expressive language, for example. Right brain is very focused on seeing patterns. However, unless your corpus callosum is severed, that bundle of nerve fibers that connects the two hemispheres, we're using our whole brain for most tasks. The next thing, multitasking is a good way to get work done. So many of us really just don't get it. And even though I talk about it all the time, I still try to multitask myself. But when I do, I realize that I may have been answering an email and I missed what people were talking about in a conversation during a meeting. So we all try to multitask, and we think we can do it because we switch pretty quickly back and forth. But the reality is there is a cost to that switching. It's called task switch cost. And what researchers have found is that when you are switching tasks within a modality, it is a little easier to get back on task than when you're switching tasks across modality. So working memory loss does occur every time we switch. But if we're listening to something, so we're in the auditory oral mode, when we're listening to something, then we listen to something else, and then we come back to listening to the first thing, we don't lose as much working memory as if we are listening, then we go to read. Now we're in the visual mode, and then we come back to auditory. That's a larger loss of working memory. So what we should all do is just focus on one thing. Hard though in today's world. Next, and I get a lot of teachers who are pretty shocked about this, and that is instructors should teach to each student's individual learning style. Educators are taught that. In fact, there are educators, many of them in schools right now, who are buying surveys to learn whether or not their students are visual learners or auditory learners or kinesthetic learners. And then they are taught that they should be designing instruction to take advantage of learning style. So let me just go back to that slide for a minute. So with learning styles, I think what we know, and here, let me go on to that. There we go. Auditory, visual, or kinesthetic. What the research is showing is that there's actually no difference in presenting things one way or another. And in fact, if there's an advantage, it's in the visual channel. And so research was done to see whether or not students who had been identified as auditory learners actually did better through the auditory channel, and same thing with visual. And again, they found no difference. So what teachers do, what instructors do typically, is to combine modalities, and that turns out to be the best way to do it. Listening to Mozart will make your baby smarter. That again was based on a small study done by some researchers, and it is actually not true. Mozart's great, but babies don't get smarter. So what you see on this slide now is a lot of what I might just call the flavor of the month in education. Those of you who work with K-12 environments know that probably every year a school district has a new focus, and even in higher ed that happens. So sometimes what I found is, as a school leader, I found that my teachers were confused about how to pull everything together. Then, as we started to really delve into the brain research and learning research, and look at, go to conferences and hear all the different topics that were being talked about, and you can see them here. How that then translates back into what one does every day seems to be problematic for a lot of instructors. So that was the motivation for the brain-targeted teaching model. What are the best practices that we know through research actually do work? And then how are those best practices supported by research from the neuro and cognitive sciences? So we're going to start with, even though this is not a linear model, which is why I have these icons in a circle, oftentimes when teachers start using this model, they start with actually down here with the learning design, what I call brain target 3. Or they may start with evaluating learning and think about how they want to evaluate what they do and then work backwards. So there's no really one way to do it. But I like to start with the emotional climate. I call that brain target 1, and I will tell you why. All of this is in the book and my website, braintargetedteaching.org, and there's a lot of free resources on that, including a reading companion and study guide, which is available, again, free of cost for download. So brain target 1 is, again, that emotional climate. I think of this as a sense of security. Thinking about a positive emotional climate and emotional connection actually promotes learning, and the research that supports this is growing every day. So essentially we know that emotion triggers attention and triggers learning, and actually they shape each other. So the science behind this is pretty well established, and that is that neural fibers from the limbic system, this system right here, information is coming in, it's coming into the thalamus, and it goes to the various parts of the brain, including this area called the frontal lobe, which is the area for executive functioning. So the thalamus sorts then this information, again, and sends it to the brain, including the frontal lobe for processing. But it simultaneously sends it to this structure here called the amygdala, which is going to be evaluating the content for emotions or threat or stress. But the trick here, as Joseph Ledoux says, there's a quick and dirty route that signal takes to the emotional processing center before it actually gets to the frontal lobe. So if you think about that, if information is coming into our emotional center right here before it comes to the thinking center, how does this influence higher order thinking? And so, as you can probably imagine, it does influence it. So we think about something called downshifting, which is a metaphor that's often used to describe how emotions that are negative cause us to process in our emotional center and have us lose focus on higher order thinking. I often ask in workshops, what does it feel like to be in a downshifted state? And so from instructors who work with little children to instructors who work with adults, the answer always is that, yeah, if students are upset about something, they're not really present. And so I ask everyone to think about, and we don't have time to do that today, but every one of you would probably have a story for me. A time when you were in school, maybe either in college yourself or way back in your early elementary days, and something happened. Maybe a teacher said something to you that embarrassed you in front of others. Or you came to class and it just had a problem with maybe another student, or you were bullied. Then when I asked candidates how they feel, typically what I always hear is I couldn't attend to the learning during that time. I've even heard things like, the teacher insulted me, told me I'd never learn math. And from that period on, I didn't pay one bit of attention in that person's class. So what is really interesting is that we know through our own experiences that being downshifted is really not good for learning at all. And unfortunately, a meta-analysis of research shows that anxiety, which causes downshifting more than anything else, accounts for about a quarter of all the emotions that students are saying they experience in schools. So there's been a lot of research recently on toxic stress and how that impedes learning. A lot of that started with animal studies and then with human studies, and looking at how that actually affects the hippocampus, which is the area of the brain that is most involved with working memory, and executive function, skills that are important for us to be able to attend, to switch tasks, to make decisions. Conversely, we know that positive emotions have been shown to increase attention, global thinking, thought action responses. Now we know that teens and really even young adults are biologically programmed to actually perceive and receive greater emotional satisfaction than regular adults in risk-taking behaviors. And so when I work with teachers who work with middle and high school students, we talk a lot about the fact that they are biologically programmed to be risk takers. But at the same time, they're really not completely myelinated in terms of brain development. And actually what we learned is that brain maturation continues into young adulthood. And so there are some who believe that really it's not until around 30 that the brain is fully myelinated. That means that the connections are all finished growing. And that time period, especially adolescence, is a really amazing time for higher order thinking and thinking about risk taking itself, for students to kind of move beyond and start to think in creative and problem solving ways. So if anyone has read this book, if you haven't read this book, I highly recommend it. It's been around for a while. Jill Bolte Taylor was a neuroscientist who had a stroke and then chronicled her recovery from the stroke. The book is called A Stroke of Insight. And this is my favorite quote. It says, although many of us think of ourselves as thinking creatures that feel, biologically, we are feeling creatures that think. So what does that mean for us now as educators working with young adults? You know, strategies is to promote a growth mindset that, you know, we're not, IQ or intelligence is not fixed. The fact that we develop cultural competencies, things like mindfulness training help with focus, social emotional learning. What we're learning is that a personal connection between an instructor and students is really important. And it's important at any age, from young children to young adults. So in higher ed, we encourage faculty to establish those personal connections and be accessible. Thinking about peer tutoring, encouraging collaboration rather than competition, especially at the higher ed level. Competition seems to be something that the students are really focused on. Clear expectations is really important. When students understand what is expected of them, how they'll be graded, and how they'll receive feedback, it seems to be much better for them in terms of how connected they feel into the course. And then allowing reasonable time for reasonable choice for students to demonstrate learning. That's a little harder at the higher ed level, but not undoable to give students choices in how they demonstrate what they know in your course. And then finally, humor is shown to reduce stress. Praise, for those of you who are working with teachers and young children, we learn that praise of intelligence does not produce, but praise of effort is much better. And so all of that is important for setting the emotional climate for learning. This is something that I think we could actually take on any level. This was done by a first grade teacher who was working in the inner city. And the kids would come into the classroom very distraught, many of them, because they had had some difficult times before they came to school. And she had a lot of behavior problems. But she started to use this technique, and that is kind of taking the emotional temperature of the students and asking them how they felt, and to write it down or to draw a picture of how they felt. So that's an example of just letting kind of those emotions, recognizing them, but then moving on. And there are many instructors who have worked with older children who have adapted this idea, and start out by just something that is maybe comical or relaxing to start the course. So next we're going to move into sense of place, the physical learning environment, and how that engages attention. So this is what a typical higher ed classroom might look like. And so how do we think about instruction and change instruction to reflect what we know about how the brain thinks and learns? One thing that we know is that novelty is important, and the same stimulus presented for a long period of time seems to reduce interest or even promotes boredom. And even ADHD subjects, when they're taught in bland kind of ways or environments, create their own stimulation. This was a study done by researchers on a group of college students. And in simple, very simple research, students learned word pairs, and they broke the subjects into two groups. One group studied the word pairs. I think it was English to Swahili word pairs that they were memorizing. And the first group studied in one room, and then the second group studied in different environments. And there were significantly better results with simply changing the environment of where students studied. I spend a lot of time looking at the physical environment, especially in K-12 schools. So I'll show you a little bit of that research too, because I do think it has relevance for any age group from little children to adults. Lighting, there's a lot of research on the effect of natural light on learning. We've been spending some time looking at noise in the environment and how that impairs recall. There's some new research about scented environments being more attractive to kids and adults. And then just being able to move around a little bit, it seems to be important. Some of us are using desks now that are flexible, that you can either sit down or you can raise them and stand. And then order and the importance of that in the environment. So in this recent study, 73% in variance of pupil performance in the studies that they were doing can be explained by these things: color in the environment, light, space, movement, fixtures, being able to access the outdoors, furniture. So I want to talk about sound for a minute. We know that music has a relaxing effect, and a lot of, we know our students probably listen to music while they're studying. And so soft background music actually can help, and it can certainly mask undesirable ambient noises in a classroom or in a study space. But when performing complex tasks, a quiet environment is better. And I usually use the analogy: if you're driving down the road and you've got your music playing and suddenly you get off on the wrong turn and you've got lots of traffic whizzing by you and you're trying to get off the expressway, what's the first thing you do? And most people will answer, you turn down the radio. So when you think about it, does the radio have anything to do with you seeing yourself, you're seeing where you're going? And the answer is maybe no, but it actually does, because that music is taking up some cognitive load. So that happens all the time. There was a meta-analysis of the effects of noise on long-term learning, and it turns out that the longer the exposure to long-term noise, the worse the learning environment. I love showing these pictures. If you have anybody, those of you who are in the education field and work with young children, a little, you know, a stimulation is nice, but this is probably overkill. And this is nice, but very stark and no student work. And this is a classroom that probably could use some warmth. But we're starting to see more and more of this kind of thing where students do have the ability to sit into different environments. And I mentioned the standing classrooms. And then the other thing is just being able to move and stretch seems to be important. So for educators, and especially for higher ed, you can create novelty, but just by changing seating configurations. You can change class locations when possible by using other parts of the campus, maybe a research lab or a theater or an art center or outdoor space, just to provide some novelty in your courses. And then think about how your course materials are presented, thinking about varying your modes of presentation. Maybe use images when you can. And then technology is also important. Okay, now we're going to go on to brain target 3, and that is a sense of purpose. So we have a sense of security, a sense of place, and now we're going to have a sense of purpose. Very important, I think, and especially for adult learners. So I'm going to ask you to look at the following words really quickly. You're not going to see them for long. Here they are. Okay, if you take a few minutes, write down a few of the words that you remember. If you don't have a pencil handy, just think about a few words. Okay, here are the words. Now, my guess is that as you look at those words and look at what you wrote, that a few of you may have written the word sleep. Okay, I betcha. Because most people do, or many people will write the word sleep when they see these words shortly. So what is happening? Why would someone write a word they didn't see? And the answer, of course, is that most of those words suggest sleep. So what the brain is doing is called patterning, and that is it's looking at how to create a whole, a concept from disparate pieces of information. And we know prior knowledge is important and acting as a filter for this. So kind of moving forward, we think about Bransford and some of the work he's done in Burns. And what they say is that knowledge is not facts and formula, but our brains do organize around big ideas. And that connections among elements really helps to assist with abstract thinking and understanding. So we really encourage graphic organizers to help students see overarching themes. And I'm going to show you some, and I'll show you some that have been used at higher ed as well. So here's some research that I like to draw back on, and that is that young children will see these first two images, and asked if they're the same or different, the children will say they're the same. And the children will say, these are children under 6, will say that these two images are different. After 6, that reverses. And from 6 all the way through adults say these two images are different, but these two are the same. So you may see what's taking place here is that here the elements are the same, and here the elements are different. But the shape here obviously is the same. So what the researchers believe is that for young children learning to decode words or learning number facts, that actually seeing component parts is an advantage. But once children become a certain developmental age, then the propensity is to see things more holistically. So there's a lot of ways that we can help students do that. The common spider web, I use a lot, and I use it in professional development a lot, where I ask the participants to think about the common thing we're talking about, and then just do a spider map, and either through pictures or words, come up with some ideas that connect with that content or that theme. I sometimes collect them, and it gives me an idea of what they've learned from the professional development or what I've missed. And then I give it back to them so that they have their own copy of it, they have it. But it gives me a good sense of, rather than assessing them, just having them design a concept map. So this could be used in higher ed a lot. Just, again, get a sense of, when you're giving a lecture, what are students getting out of it? And if you see that there are pieces that they're not getting, having a concept map is a great way to find that out. There's different kinds, obviously. This is a map that a group of faculty did together. They were teaching conflict and resolution, 20th century warfare. And actually, this was a group of instructors in Puerto Rico. And so they focused on the Vietnam War and Puerto Rico's involvement. And at the end, they really had an idea of all of the different elements that would go into how they teach this part of a course. And we're able then to design something to give their students kind of an upfront idea of how these different elements are going to be fitting together throughout this part of the course. Here's an example of ancient Greece. And I'll start at the top here. Studies showed that a 40% improvement in understanding when students see the general idea first. So here was a course on ancient Greece, and the instructor wanting the students to know, here are the elements that we're going to be studying, and here's how they all fit together. This was one done by an elementary teacher, but I like the structure of it, and I think it could be used anywhere on any level, and that is, you'll need to know so that you can. Because we want students to know the content that they're going to be learning, but we also want them to know what they're going to be doing with that content. So I thought this was a nice example, no matter what age group you're teaching. This was someone who teaches technology and wanting the student to know about digital footprints. And so that's a concept map to tell them what they were going to be doing during that unit to determine digital footprints. This was done by a group of math teachers who were using a concept that I think is really great. In the red boxes, this is what you already know. This is your prior knowledge. The green box, this is what we're going to be doing during this unit. And then the blue boxes, this is what we're going to, these are the strategies we're going to use to learn that objective. So it gives the students a sense of the unity of everything first. So this is at Johns Hopkins. Dr. Lessig teaches bioinformatics at our university. He teaches undergraduate, graduate, and doctoral students. And so he uses the brain-targeted teaching model all the time. And here's an example that he shared of pairwise alignment. And he said once he started to use these concept maps, that his students really did grasp the content, which can be nucleotide and protein sequences. It could be complicated for some students, but it really did break it down. Here's another one that he uses that I thought was really great, and this could be used at any level. He uses this in his Intro to Biostatistics course. And you can see here types of data types and graphs, and I can see 1, 2, 3, 4, 5, 6 different types. And then some types actually break down even further. So there's lots of different ways to display data so that students really see it in a better way. So one of the things, whether you're teaching young children or higher ed, you're going to look at what it is you're supposed to be teaching, what those standards are. Content standards like Common Core, or professional standards. If you're teaching a special education course or you're teaching a science course, you're using standards for your professional organizations. And then breaking that down into your scope and sequence, breaking it down then further into your learning units, breaking those learning units into graphic organizers, and then seeing what those broad learning goals are, designing your instructional activities and your assessments. And they all should align, as we know. Our assessments, especially those of us in higher ed, working with accrediting agencies, are looking more and more about how assessments map right back into our standards. And this is a way to make sure that happens. So, strategies, again, content themes, alternative modes of presentation, and then to determine how content themes will be evaluated. Okay, now we're into Brain Target 4, and we want students to master content. We've designed a sense of security, a sense of place, a sense of purpose, and now we want them to be able to master what we teach them. So we're going to start out with Lucy, and she says, hey, Charlie Brown, guess what? I taught Woodstock to whistle. And Charlie Brown says, that's funny. Woodstock can't whistle. And she smiles and says, no, stupid. I said, I taught Woodstock to whistle. I didn't say you learned it. So how many times do we say we taught them, but at the end of the day, we didn't get back what we wanted? Well, learning and memory are connected. And one of my heroes is Eric Kandel, who wrote a great book called In Search of Memory. Eric received the Nobel Prize for his discovery that actually the brain creates new proteins when information goes from working into long-term memory systems. And so I love this quotation. If you remember anything of this book, it's because your brain is different after you've finished reading it. When he talks to educators, he calls them neuroplasticians. And he says, you're neuroplasticians because when students leave your course and they know something that they didn't know before, their brains have changed. So how do you get there? Well, rehearsing and repeating, but then there are elaborations. So information, as we talked about before, sensory information comes in, it goes to short-term store, which then is working memory, which is a little bit longer, but really what we want is long-term storage. We want students to be able to take information and be able to apply it later in real-world context and other coursework. Now, we've looked at a lot of information about the arts and the effect of arts on learning. And so I want to talk to you really quickly about that. You know, we know arts education is important, arts and cultural experiences are important, but integrating the arts into how we teach is something that my team and I have done some work with, and I want to show it to you very quickly. The question is there any evidence? And we know from those of us in higher ed that evidence is not correlational, it's causal. So we were looking to see, is there any causal research out there that shows that the arts actually improve learning? And we found lots of correlational studies, but no causal studies. So we conducted 2 randomized controlled trials in Baltimore City. We wrote treatment and control units. We were targeting science instruction at the 5th grade level. And so arts integrated versus conventional instruction was what we were testing. And we matched them according to the content in both conditions, the timing of the activity, how long each activity took in both conditions, and the mode of presentation. So in the treatment, we used every art form that there was. And in the design, I'm going to show you teacher 1, for example, taught astronomy. And this was, the red represents a randomized group of students who learned astronomy in the arts integration condition. Then that same group took environmental science after that in the non-arts integration from a different teacher. So this teacher then taught a different group in the non-arts way. So it was a way to control for teacher effect. And so we showed children using something called Tableau to show the states of matter. These children are showing solids, and then how liquid molecules, and then gas molecules. Astronomy students designed a poster, The Adventures of, what is it, Tommy the Star. Here students were using their body to show shapes of galaxy, and here students designed puppets and did visual arts. So what did we find? We found that long-term retention, that is, we did pre, post, and delayed testing, and there was advantage for arts integration and long-term retention. Actually, there was no difference right after the unit was done. So post-test, no difference. Long-term retention favored arts integration. Here are kids at the basic level of reading instruction, and they benefited the most. And you can see the decay of memory here in the arts integrated condition is much less than in the control condition. And this is in the Mind, Brain, and Education, this article. There are a lot of other ways of improving memory that I won't get into, but spacing, not doing everything at once, but spacing, intervals, interleaving, going from one task to the next and then back to that task again. Chunking, desirable difficulties means that we go a little bit harder than we want with our students, and that really motivates them to move on. And mnemonic devices. Okay, so now we're going to go into application. Lots of times when teachers see that students master content, they think they're finished and then they move on. But in this model, we really do encourage application, and that is the ability to apply knowledge meaningfully. And so this really means extending what they've learned into creative problem-solving tasks. The 21st century skills movement is all about that: innovation, creativity, collaboration, and problem solving. And it's not content or creativity, but it's both. So how well are we doing with that? Not well. The workforce needs. Here are some headlines that show that when students are leaving K-12 and college education, that our grads, let's come down here, 40% of college grads lack skills necessary for the workforce. So what businesses are saying is that they may know something, but their talent, how they're able to apply it, is lacking. The skills employers wish college grads had. Wanted new ideas for closing the skills gap. So what this all means to us is that creativity actually should be part of what we teach. And can it be taught? And it can be. Research findings support that it's pliable, that all students can be taught to think creatively, and creatively and intelligence are different constructs. And we know that there are measurable brain changes through creativity. Here's how we know. Here's an fMRI machine. And one of our researchers at Hopkins, he's now at Berkeley, but his research was in bringing jazz musicians into his lab, and they played a jazz piece that they had memorized, and then they were cued to improvise jazz. They had a small piano that they were able to take into the scanner. So what were the results? Well, there's a lot here, but I will show you this. What's bolded is that he found that the area in the brain, what it says here went up, that means it was more active. In the area of the brain, the medial prefrontal area, which is autobiographical. This is our area of self-expression. And the lateral prefrontal regions, which would be along each side, which is more self-inhibitory and self-censoring, that part of the brain actually decreased or went down, less activity there. And so Charles Lim is the researcher. He has some TED Talks and he's a great speaker, so I would encourage you to take a look at his work. But he thinks that this is one of the neural correlates of spontaneous creativity. So what that means to me is that the brain does process differently in creative thinking, what we call convergent thinking, where there's a right answer and a solution, versus divergent thinking, and that is that the students generate multiple and varied solutions. So it's not one or the other, but that magic synthesis that actually creates flow which is what we want our students to do, and it's what the workforce is expecting. So what does creativity look like in the educational setting? I'm going to go through these quickly because we're kind of coming to an end here. Open-ended prompts, post questions with more than one correct response, ask about implications and implementation of each solution, include opportunities for group work, novel relationships, provide students with unrelated ideas and ask them to find novel relationships. And so there's a lot of strategies that can be done, but we're going to move on because I have about 5 minutes more with you to the last brain target, and that is 6. And that is evaluating learning. So we've talked now about the climate, the emotional and physical. We've talked about design, big picture. We've talked about mastery and application. And now we're going to talk about the ability to demonstrate mastery and application and using evaluation as a way to reinforce learning. So there are 4 main areas that we talk about here, and I'm not going to go into all of them, but I'll touch on some of them. And that is frequent and useful feedback, allowing students to actively retrieve information, spacing over time, periods where we're making assessments, and then allow for artistic thinking and problem solving. Here's a study that I'd like to show you, and that is that researchers found, this was done with young adults, that just the anticipation of when students were going to get their grades back improved performance. So if students were told that they were going to hear back right away, this is the level of performance, and you can see that slope. This group was told that they would get that they would get feedback 17 days later. So the study here is that the anticipation of feedback may enhance performance because the threat of disappointment is more salient. Now, we often study until we think we know something and then we stop. But that has been shown over and over again that active retrieval is much better than passive studying. So here's the seminal study on this. There were 4 different groups. Again, it was Swahili English word pairs. The first group, after they had an initial assessment where they were able to master, then they were told they were going to be given another assessment to see their mastery. But in the interval, this group, ST, repeated studying and repeated retrieval through quizzes. This group, second group, did not study, but had repeated quizzes. This group had repeated studying, but only was quizzed the first time. That was it. And this group did no repeated studying at all. Nothing. Here are the results. What's really interesting to me is that the group that studied and tested and the group that only tested did the same. But the group that only studied did about as well as the group that did nothing at all. So what does that mean? Well, I will give you an example. My daughter, in her first year of med school, did not do as well the first month as she was used to doing in school and couldn't figure out what was going on. And I said to her one day, well, how are you studying? And she said, well, I'm going back and I'm listening to the lecture, and then I'm going back over my notes and I'm underlining and highlighting. And she said, if I get time, I do the quiz. So I said, well, you're doing only input and you're not retrieving. So do the opposite. And so she did do the opposite, and voila, it worked. So she then realized her mother probably knew something. So repeated retrieving produces, repeated studying produces poor retention. Spacing is important and even better, but when your students are studying, have them give themselves quizzes, because that makes sense. When they're just rereading or underlining or listening to lectures again, it's input and it doesn't recruit memory. But when you have output, such as you make up a concept map or you take a quiz, you quiz yourself, you're actually recruiting memory traces because you have to come out with output. And we can think about how to be creative. This is a second grade teacher who had kids taking a traditional test, and then she tested them in a different way, design a farm. And she asked them to be creative in the design. So in reflection, all the topics that you heard, what should all instructors know from this field of neuroeducation? And I would just have to say that looking at these 6 brain targets, you could adopt some of them, none of them, or all of them. But, you know, I think paying attention to what this research says and thinking it through within a framework that takes you from emotions all the way through to evaluation has shown to be helpful. Here's some research we've done very quickly when this is after a 30, 45-hour professional development. The frequency was very strong in how they used it in practice, very strong in how they felt that improved student learning, their overall practice, and incorporating, it was easy to incorporate into their instruction. Then we did some research on teacher efficacy, that is teachers' understanding. General efficacy is I know how to teach. Well, teaching in general makes a difference, and personal efficacy, I have the knowledge of how to teach. And I would say at the higher ed level, personal efficacy may be something that needs to be worked on. You know, people believe that teaching makes a difference, but some are less confident. They know the content, but maybe less confident that they can take that content and have students actually learn it. So I'm going to go through some of these really quickly, but I'd like to kind of end with this one here, this last one. The influence of a student's home experience can be overcome by good teaching. And what we did was to take our sample and compare it to 600 teachers from Virginia who had not taken our training. So our teachers are in blue, and the matched sample is in red, and then the full sample is in green. And so bottom line is that in general efficacy and in personal efficacy, after taking this training, the teachers who were trained in the brain targeted teaching model felt much more efficacy, that they knew how to get students to learn better. So I think I'll end with that and let you think through what should teachers know, what should educators know from the learning science, especially about creativity. How do we teach it? How do we recognize it? Those are the 2 books I've written on the model. And I want to end by thanking you for inviting me. And if you have maybe a couple minutes, I'm here for a question or 2 if anyone has one.
I have a question.
Sure.
Thank you so much for this presentation. I'm Amy Roberts, and I'm in the Master School of Nursing. And I was wondering about Brain Target 6, and particularly if we did quizzes, allowed them to get some kind of feedback. What do you think then about a comprehensive final exam that has a lot of application pieces? What has been your experience with that?
So I think you're asking that quizzes are probably lower level and the comps are more application based. Is that what you're saying?
Well, with what you said, I was thinking about having we try to have a lot of application.
Yeah.
With what you said is to have some quizzes, then they get some feedback, and then to do more application. That made me think of having, like a 90% application final. That would be comprehensive.
So the research that Yeah, so I think I understand what you're saying. The research that was originally done was in quizzes, which is again a pretty low level assessment, right? I mean, it's probably true or you know, just maybe picking out 1 out of 4. But these researchers replicated this study in a lot of different ways of assessing, including project-based learning, okay, which is application, and found the same thing, that when students had the opportunity to apply what they're learning in frequent ways, that when they got to that final assessment, they were able to do better. So I guess what I'm saying to you is, if the assessment, the final assessment they're taking is application based, then the retrieval periods should be mimicking that, right? Should be more application based assessments. Does that answer your question?
Yes.
Okay.
I have a question about how much, is there a percentage of like the content that needs to be on the quiz? Is there like a sweet spot, like a best practice for like 5 questions per lecture? Do you know what I'm saying? And is each lecture repeated, or is it the big concepts of the course? I'm not sure about the details about how to do the repeated retrievals.
Yeah. You know, I don't know of research that actually has pinpointed that. And, you know, my advice is it's probably trial and error, right? I mean, you know, what I would probably be doing is thinking about, you know, again, those terminal content objectives. You know, what are the big pictures? What are the takeaways that they have to have for the course, or for the section of the course that you're teaching, the content you're teaching, and, you know, design some, you know, whether it's a quiz. I actually think quizzes are fine, but I wouldn't be doing quizzes. I would be doing things like concept maps, and, you know, asking them to do a concept map of what they learned the day before, and, you know, have them retrieve that way. But I mean, you could do it any way you want, or you could give them a you know, a problem that would have them apply what you taught in the lecture the day before. So I think, you know, again, depending on your content and your students and your class size and what works best for you, you know, I would just play with it a bit and see what works best in your course.
I have a question.
Mm-hmm.
You can hear me. Okay.
Yep.
Okay, hi, I'm Angela. Whenever you talked about using concept maps, I was wondering, so, you know, there's a lot of things about how students like consistency. So do you recommend using multiple, I guess, low stakes, multiple ways of retrieving that information? So do a concept map 1 week and then a quiz another week? Or is it better for students for them to know, okay, after I look at this content, she's gonna ask me for a concept map, you know, for each different module or whatever? Is it better? Does that make sense, that question?
Yeah, so, you know, it's interesting to balance predictability and consistency with novelty. And that's the thing that you know, again, teachers have to find the sweet spot of that. Basically, what I generally tell the teachers that we're working with, the instructors that we're working with, is to be consistent in the framework of what you're doing, but within that consistent framework, introduce novelty. So that means something different for everybody, frankly, you know, depending on the age you're teaching and the content you're teaching. You know, it's so let's talk about young adults. It would probably be a little jarring for them that they don't know what you're looking for. I think that's the thing that I think that's hardest for them, that they don't know what you're looking for. Are you looking for straight up retrieval, or are you looking for application? You know, we were doing a study of someone who was not being successful in their teaching at the college level. And as it turns out, every assessment that they gave through the semester was looking for retrieval of content. But then in the final exam, the whole exam was application. And the instructor could not figure out why the students did so poorly in the exam. And it was because, again, they didn't match what they were doing during the course with the final assessment. So again, I think that it comes back to thinking about your concept maps, and the students know these are the areas that I'm going to be assessing you. Here are the big picture concepts, and here's how they fit together. And you better know about these, right? And then through the course, giving them, if it's an application-based assessment, then giving them opportunities to apply that, apply knowledge through active retrieval activities. And it could be arts-based activities too. I think at the higher ed level, it's a little bit more difficult for them to think about incorporating the arts into what they do. However, I will tell you that those who have loved it. Just giving students the opportunity to write a paper or do something artistic to show their mastery of some content, thought that it made the course a lot more fun.
Thank you.
Anything else? Well, thank you so much for your time this afternoon, and move forward as neuroeducators.
Thank you so much.
Thank you. So Julie, thank you, and hopefully we'll have a chance to connect again sometime.
That would be great. I appreciate you coming. Thank you so much.
Bye-bye.
Bye.
Main meeting.
The
Stop.
end meeting.
Down at the bottom.
End
Down at the
meeting
bottom.
on.
There we go. Thank you. Just leave. We can move on.